Now, in this lecture, we find out the area of a square. In the drawing, we have the right triangle ABC. Inside the right triangle ABC, we have square DEFG. And our mission is to find out the area of this square DEFG. In addition, we know that the side AB of the right triangle ABC equals to 5 units in its length. Side BC equals to 12 units in its length. This is angle ABC, that is the right angle. Again, our mission is to find out the area of this square DEFG. So first of all, we will implement the Pythagoras theorem on the right triangle ABC. So, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the abbreviation for Pythagoras theorem. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and AC square must be equal to AB square plus BC square. Repeat again, according to the Pythagoras theorem in the right triangle ABC, AC square must be equal to AB square plus BC square. So AC square equals to AB square. AB is 5, therefore AB square is 5 square, that is 25, plus BC square. BC is 12, therefore BC square is 12 square, that is 144. In conclusion, found out that AC square equals to 25 plus 144. 25 plus 144 is 169. So AC square equals to 169. Here we take a root out of this equation and finally we get that AC equals to the square root of 169, that is 13. So the length of the hypotenuse AC is 13 units, so I'll write it down. In the next step, we'll define the length of line segment BG as X. So what is the length of line segment GC? From the drawing it is very easy to see that GC equals to BC minus BG. Again, BC minus BG equals to GC. So GC equals to BC, that is 12, minus GC, that is X. So in total, GC equals to 12 minus X. In the next step, we define the length of one side of this square DEFG as L. So DE equals to L, and therefore all the other sides must be also equal to L, because of the fact that all the sides of any square are equal to each other. We have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. AC is the hypotenuse of the right triangle ABC, therefore it is absolutely a straight line. So if you focus on the lower side of this straight line AC at point D, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is 90 degrees plus the missing angle. In total, they must be equal to 180 degrees. So the missing angle must be equal to 180 degrees. Again, in order to complete the sum of the angles in the lower side of the straight line DC at point, in the lower side of the straight line AC at point D to 180 degrees, the missing angle must be equal to 90 degrees in its size. Likewise, if you focus on the lower side of the straight line AC at point E, here the sum of the angles must be equal to 180 degrees according to the same rule. So, which angles we have at the lower side of AC at point D? We have this angle that is 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. So the missing angle must be equal to 90 degrees. In the next step, we define this angle, the actual angle ACB as alpha. And we focus on the right big triangle, triangle ABC. On the right big triangle, triangle ABC. This angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. So therefore, the missing angle here must be equal to 90 degrees minus alpha. We define 90 degrees minus alpha as beta. And therefore, the missing angle here equals to beta. We have the equation that 90 degrees minus alpha equals to beta. If we add to this equation alpha and subtract beta simultaneously, we will get that 90 degrees minus beta equals to alpha. In the next step, we will focus on the right small triangle, triangle ADF. In the right small triangle, triangle ADF, this angle equals to beta. This angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha. Therefore, the missing angle must be equal to alpha. Likewise, we focus on the small right triangle, triangle EGC. The small right triangle, triangle EGC. This angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta here, and therefore the missing angle here must be equal to beta. BC, nice angle BC is one side of the right triangle BC, therefore it is absolute straight line. So if we focus on the upper side of the straight line BC at point G, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line BC at point G? We have this angle that is beta, this angle that is 90 degrees, plus the missing angle. In total, the sum of those three angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles of the upper side of the straight line BC at point G. Therefore, the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, and therefore the missing angle here must be equal to alpha. In the right triangle FBG, the right small triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, and therefore the missing angle here must be equal to beta. So in the drawing, we have in total 4 right angles. 1, 2, 3, and the right big triangle, triangle ABC. Actually, each right triangle have the angles alpha, beta, and 90 degrees, and therefore all the four right triangles, all the four triangles are actually similar to each other according to angle similarity rule. Why? Because all the three angles in all the other triangles are corresponding correspondingly equal to each other. Why? Because each right angle has the angles alpha, beta, and 90 degrees, and therefore all the four right angles are similar to each other according to angle similarity rule. For example, the big right triangle ABC is similar to this small triangle FBG. This small right triangle FBG. Why? Because they have exactly the same angles, alpha, beta, and 90 degrees. So write it down. The big right triangle ABC is similar to the small right triangle FBG according to angle similarity rule. And for the fact that the two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that BG over FG in the right small triangle FBG is equals to BC over AC in the right big triangle ABC. Repeat again. We will derive that BG over FG equals to BC over AC. So this is equation 1. So BG is X over FG. FG is L. And it is equals to BC, that is 12, over AC, that is 13. In conclusion, we found out that according to equation 1, X over L equals to 12 over 13. Here we multiply this equation 1 by L, and we get that according to equation 1, X equals to 12L over 13. And again, according to equation 1, X equals to 12L over 13. Likewise, we know that the right big triangle ABC is similar to the right small triangle EGC. So I write it down. The right big triangle ABC is similar to the right small triangle EGC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that GC over EG in the right triangle EGC is equals to AC over AB in the right big triangle ABC. Repeat again, we derive that GC over EG equals to AC over AB. So GC is 12 minus X over EG. EG is L. And it is equals to AC, that is 13, over AB, that is 5. In conclusion, found out that according to equation 2, 12 minus X over L equals to 13 over 5. Here we cross multiply this equation 2, and we get that according to equation 2, 5 times 12 minus X equals to 13L. Here we'll open the brackets on this side of this equation 2, and we get that according to equation 2, 5 times 12 is 60, 5 times minus X is minus 5X, and it is equals to 13L. Here we add 5X to this equation 2, and we get that according to equation 2, 60 equals to 13L plus 5X. Here we subtract 13L from this equation 2, And you get that according to equation 2, 60 minus 13L equals to 5x. You can substitute here in this equation 2x, by the value of x that we found here in this equation 1. According to this equation 1, x equals to 12L over 13. Therefore, we can substitute x in this equation 2 by 12L over 13. We do it now, and we get that, that according to this equation 2, 60 minus 13L equals to 5x, and x equals to 12L over 13. In conclusion, found out that 60, according to equation 2, 60 minus 13L equals to 5 times 12L over 13. So 60 minus 13L equals to 5 times 12L is 60L. So in total, this expression equals to 60L over 13. Here we'll multiply this equation 2 by 13. And finally, we get that according to this equation 2, 60 times 13 is 780. 13 times minus 13L is minus 169L. And it is equals to 60L. Repeat again, according to equation 2, we actually found out that 780 minus 169L equals to 60L. Here we read to this equation 2, 169L. And we get according to this equation 2, 780 equals to 60L plus 169L equals to 229L. Here we divide this equation 2 by 229. And finally we get that L equals to 780 over 229. Actually, 780 over 229 is equal to 3.40611 units. So L, that is the length of one side of square DEFG, is equal to 3.40611 units. Is the length of one side of this square DEFG. And we know that the area of any square is equal to the length of one side squared. In this case, it will be L squared. So the area of this square DEFG will be equal to L squared. L is 3.40611, therefore L squared is 3.40611 squared. 3.40611 square equals to 11.6016 square units. In conclusion, we found out that the area of square DEFG is equal to 11.6016 square units. And that is the answer to the question. I repeat again. The area of this square DEFG is equal to 11.6016 square units. So in the next step, I will summarize the lecture. In this lecture, we found out the area of this square DEFG. In the drawing, we have the right triangle ABC. Side AB of this right triangle ABC equals to 5 units in its length. Side BC equals to 12 units in its length. This is angle ABC, that is a right angle. And our mission is to find out the area of this square DEFG. So first of all, we implemented the Pythagoras theorem in the right triangle, triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. In the right triangle ABC, it means that AC square equals to AB square plus BC square. Repeat again, in the right triangle ABC, according to the Pythagoras theorem, AC square equals to AB square plus BC square. So AC square equals to AB square. AB is 5, therefore AB square is 5 squared, that is 25, plus BC square. BC is 12, therefore BC square is 12 squared, that is 144. In conclusion, found out that AC square equals to 25 plus 144. 25 plus 144 is 169. So AC square equals to 169. We took out of this equation and finally found out AC, the length of the hypotenuse AC is equals to the square root of 169, that is 13. So AC equals to 13 units in its length. In the next step, we defined the length of this line segment BG as x, and therefore GC equals to BC minus BG. Again, BC minus BG equals to GC. So GC equals to BC, that is 12, minus GC, that is x. In total, GC equals to 12 minus x. Then we define the length of one side of this square DEFG as L, and therefore all the other lengths must be also equal to L, because of the fact that all the sides of any square are equal to each other in their lengths. And then we defined this angle, that is actual angle ACB as alpha, and we focus on the right big triangle, triangle ABC. In the right big triangle, triangle ABC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees, that is the sum of the angles in any triangle. So the missing angle must be equal to 90 degrees minus alpha. But we define 90 degrees minus alpha is beta, and therefore the missing angle must be equal to beta. Here we have the equation that 90 degrees minus alpha equals to beta. We added to this equation alpha, and then we subtract beta simultaneously, and found out actually that 90 degrees minus beta equals to alpha. Then we focus on this right small triangle, triangle ADF. In the right small triangle ADF, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle must be equal to alpha. Likewise, we focus on the right small triangle, triangle EGC. In the right small triangle EGC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle must be equal to beta. We know that BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line BC is point G, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line BC at point G? We have this angle that is beta, this angle equals to 90 degrees, plus the missing angle. In total, the sum of those three angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles on the upper side of the straight line BC at point G. Therefore, the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta is alpha, therefore the missing angle here must be equal to alpha. In the right small triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here must be equal to beta. So, in the domain, we have in total 4 right angles. 1, 2, 3 in the right big triangle, triangle ABC. All those 4 right angles are similar to each other according to angle similarity rule. Why? Because all the right angles have exactly the same 3 angles, alpha, beta, and 90 degrees. Therefore, all those 4 right angles are similar to each other according to angle similarity rule. For example, the big right triangle ABC is similar to the small right triangle, triangle FBG. Repeat again. The big right triangle ABC is similar, this is the side of similar, to the right small triangle, triangle EGC. the big right triangle ABC is similar to the right small triangle FGB. FBG according to angle similarity rule. Here, the big right triangle ABC is similar to the small right triangle FBG according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that BG over FG in the right small triangle FBG is equals to BC over AC in the right big triangle ABC. I repeat again, we derive that BG over FG equals to BC over AC. BG is X, FG is L, AC and BC is 12, and AC is 13. So in conclusion, found out that according to equation 1, X over L equals to 12 over 13. Here we multiply this equation 1 by L, and finally found out that X equals to 12L over 13. Okay, so according to equation 1, X equals to 12L over 13. Likewise, you know that the right big triangle ABC is similar to the right small triangle EGC according to angle similarity rule. I repeat again, the right big triangle ABC is similar to the right triangle EGC, therefore the following relationship exists between their sides. GC over EG in the right small triangle EGC is equals to AC over AB in the right big triangle ABC. I repeat again, GC over EG equals to AC over AB. GC is 12 minus X, EG is L, AC is 13, and AB is 5. So in conclusion, found that according to equation 2, 12 minus X over L equals to 13 over 5. Here we cross multiply this equation 2, and found out actually that 5 times 12 minus X equals to 13L. Here we open the brackets on this side of this equation 2, and finally found out that 5 times 12 is 60, minus 5x equals to 13L. Here we added 5x to this equation, and found out that 60 equals to 13L plus 5x. Here we subtracted 13L from this equation 2, and finally found out that 60 minus 13L equals to 5x. So in this equation, we can substitute equation 2, we can substitute x by the value that we found out here in this equation 1. According to this equation 1, x equals to 12L over 13. Therefore, we can substitute x in this equation 2 by 12L over 13. We did it, and we found out actually that 60 minus 13L equals to 5x, and x is 12L over 13. So 60 minus 13L equals to 5 times 12L is 60L. So in total, this expression equals to 60L over 13. Here we multiply this equation 2 by 13, and we found out that 13 times 60 is 780, minus 30L times 13L times 13 is minus 169L, and it is equal to 60L. I repeat again, according to equation 2, we actually found out that 780 minus 169L equals to 60L. Here we added to this equation 2, 169L, and finally found out that 780 equals to 60L plus 169L equals to 229L. In conclusion, found out that according to equation 2, 780 equals to 229L. Here we divided this equation 2 by 229, and finally found out that L equals to 780 over 229, that is actually 3.40611. So the length of one side of this square DEFG is 3.40611 units. And the area of any square equals to the length of one side squared. And therefore, the area of this square DEFG will be equal to L squared. The area of square DEFG equals to L squared. L is 3.40611. Therefore, L squared is 3.40611 squared. That is actually equals to 11.6016. In conclusion, found out that the area of this square DEFG is equals to 11.6016 square units. Okay, thank you very much.